Anyone in this class from the northern part of the India, which is very cold? Anyone? Kajal? Prabhat is from Bihar. Where exactly in Bihar? Yeah, okay. What's the temperature? 5 degrees. Oh my God. That's pretty cold. Kajal, you are from? Oh, near Roorkee. And that might be quite cold. Bihar is near Nepal. Rajasthan, 8 degrees. Oh. What is the temperature during daytime? That is a minimum temperature, right? 5 degrees, 8 degrees. Prabhat, Rakesh, 12, 13. 6 degrees in Noida. Oh my God. And I'm sure you still attend morning 8 o'clock lecture, huh? From Noida. Good, good, good. Okay, shall we start? Kajal, you are from which place? Bihar, near Nepal. You are Kajal or Kajal? Kajal, right? Aksaul. Okay. Here in Nagpur, we have two medical colleges, and in both these medical colleges, there's a head of the department in orthopedic department, and his name is Sajal Mitra, and his brother, who is director of one of the private medical colleges, his name is Kajal Mitra. So probably they are twins, and the names are Sajal and Kajal. Interesting. Okay. Would like to visit this place sometimes. Must be beautiful. Okay, which color looks more prominent on the screen? This indigo, black, blue, red. Ayush, whatever color I'm using, is that okay? Okay. Okay, let's start. Uh, Today I want to complete this topic spur gear design. If the rating is 45, then will it require power? 42 and will it supply total 45? If the rating is 45 and it supply, will it what is this? Although the question is not very clear, but the required power is 42 and the motor rating is 45. This is your question, right, Saurabh?
Yes, ma'am.
Okay. Normally for a 45 kilowatt motor, which is a rated power, the design, it is always designed for a little higher than that. Like we have used the service factor 1.5, which is making the design power as 67.5. which means even if you exceed 45, even if the power required is 50 kilowatt, it will supply that much power. But 45 kilowatt is something which it will definitely supply. And what happens is with more number of cycles and usage, the motor is also aging. Even that is getting older and older, which means there would be more wear and tear, there would be more losses. And after maybe 5 years, after 10 years, its power generating capacity goes down. So probably if initially it is supplying 45 kilowatts, after 5 years it will supply only 42 kilowatts. Now 5 years is a relative term which depends upon what are the service conditions, where exactly it is used, how many hours it is used. To share you an example, we were working on energy audit kind of consultancy of one of the textile industries near Nagpur. There's a place called Sauner. They are into this textile business, and their problem was their electricity bill was coming out to be in few lakhs every month, some 2 or 3 lakhs every month, and they wanted us to check for where exactly are the losses. So we had a team of 3, 4 professors, two from electrical and two from mechanical, and we realized that they have not changed their motor for so many years. So almost for 20 years they have been using the same motor, which means the losses are very high, which means the efficiency is pretty low. And as per our consultancy recommendation, we asked them to simply change the motor. Now, changing the motor will be an initial cost, a one-time cost, but that would save their power by 30%. So 30% saving is huge saving. And they were saying that they are simply changing the motor windings. You have studied in electrical engineering, motor will have a stator and a rotor, and it will have those copper windings. So if that is changed, it is like a servicing of your vehicle, but it still is an old vehicle, right? It still is an old vehicle. You also know the fact that these days on the roads, any vehicle more than 15 years and RTO will not give a green clearance. So that is the reason is after 15 years of continuous operation, the vehicle, the gearbox, the engine, the belt drives, all the shafts, all the joints, everything will undergo wear and tear, and its performance on the road decreases. The pollution would increase. So it is better to replace that vehicle instead of simply getting it serviced or overhauled. Is that clear? Pretty big answer, I guess, for the small question. Acha, so today we are going to discuss about the second part of this two-stage gear transmission. So second part, I'll go a bit faster because that is a yes. Somebody is asking. So it will be more like revising whatever we have done in the part one, and then we'll design the gear plank, we'll design the complete hub and the shaft. So this should also include shaft design, which will hold true for belt pulleys also, for bearings also. You have to design the shaft. Well, let's start with the second part of the design for the gear P2G2. Yeah, now I am expecting answers from all of you. Quickly tell me what are the values for RPM available at the shaft. We had a motor. On this motor, there was a pinion which we had already designed, meshing with another gear. This is the motor. And here the speed was reduced from 1440 RPM to 240. Yes. And at the next stage, this one was P1 pinion, gear G1. Is my voice loud and clear? Somebody was saying the voice is too low. And then you have this P2G2 operating a drum, and this rotating drum is lifting the weight. Okay, good. So this pinion P2 is again rotating at 240 RPM because this is mounted on the same shaft, and this gear G2 is rotating at 42.44. 42.6 or 4? Okay. And what is the power available here at this shaft? Whatever is the power here, you divide it by efficiency, or whatever is the power here, you reduce it again, multiply it with the efficiency, 98%. So what is the power available here? Forty-four kilowatt. The design power here which was available was, हमने मोटर तो भी 45 किलोवाट दिया है, right? This motor is 45 kilowatt. Now we are starting from here. If this is 45 kilowatt motor with the service conditions saying service factor is 1.5. So what was the PD of this motor in the first part of the problem? 45 kilowatt into the service factor. This gave 67.5. So how much would be the losses from the shaft 1 to shaft 2 because of the gear drive? What is the efficiency of the gear drive? I told you. What efficiency we assumed? 98%. So यहाँ से यहाँ power कितना कम हो जाएगा? You multiply it with 98%. So the power available at the shaft 2 or at pinion P2. You multiply it with 98% and this would be the power available at the shaft 2. 66.1. Should I take it 66 for ease? Let me quickly revise. We had some load acting here and we knew the rotating shaft diameter and its linear speed, from which we calculated what is the power required at this drum or the elevator. And from here we divided the efficiency of this gear pair and the efficiency of this gear pair, and we got some value around 41 kilowatt of the power is required at the motor. And then since 41.5 is not a standard rating of the motor, so we selected 45 kilowatt motor power. So a motor with rating 45 kilowatts, and for the service conditions that are given, we multiplied it with the service factor and we got 67.5 kilowatt should be the design power for this motor or the entire assembly. And since we have designed P1 G1 for 67.5, we continue with the same design power. You can slightly reduce because of gear drive, there is 2% loss, and so the power available here is 66 kilowatt. 66.15, okay. Yeah. Should we proceed from here? What is the next step? What is the next step? Design the pinion. Before that, what is the static load? PD upon velocity of this pinion P2. For getting the velocity of the pinion P2, we need diameter of the pinion P2, for which we need the module. So let us assume the module is M. If you want, you can go with M1 or M dash something. This is for the design of gear pair P2G2. Let it be M. And so diameter of this pinion will be M times number of teeth. How many number of teeth you want to take for this pinion? 25. Good. So it is again 25 m. So what is the peripheral velocity? RPM is 240, dp is 25 m in millimeters. Pitch circle diameter of the pinion into the speed in RPM by 60. Okay, this is 0.314 times m, and the unit is, what is the unit? Vaishnavi, meter per second. Good. Next. So give me FT in newtons. PD you know is 66 kilowatt. Convert it into watts upon peripheral velocity. Something by m. Give me that something. 211, 210. Why this variation? If you're using 0.314 and 66. 210, okay. N cube. What next? We select material. Give me material for pinion and for gear. Refer the design data book. We can use same material as the ones which we used in the first stage, or you might go with some other material. What do you want? Same? Same, okay, good. So for pinion, we used SAE 1045, right? Forged carbon steel SAE 1045. What is the value of S naught? 210. And for gear, we used cast steel S naught 196. Okay. Number of teeth. For pinion, number of teeth is 25. So what is the number of teeth on gear? What is the velocity ratio? Velocity ratio कितना है? 5 point something something. 5.6, which gives number of teeth as 142. Ratio of their RPMs inversely proportional to ratio of their teeth. So for TP and TG given, give me the value of Lewis form factor Y. 20-degree full depth involute teeth. Refer design data book, give me the value of Y. We have to check whether pinion or gear, which one is stronger. Well, it is 0.37. Others, are you getting same answer? 0.37 and 0.46. Good. So compare and tell me which one is weaker. S naught into Y. For pinion, what is the value? And S naught into Y for gear. What is the value? Quickly, everybody please post your answers. It's not important to be the first one to give the answer, but all of you are at least involved. That is what I wish to know. What is S naught into Y for pinion? This is coming out to be 77. Okay, and for gear it is 91. And so pinion is again weaker. So we design for pinion. Design for pinion. What is the next step? Good, 77 and 90, correct? Yes. What is the next step? Once we know that we are designing for pinion, we have to find the beam strength for the pinion. And the formula goes as S naught into Y B M and CV. Value of VP is not known, so we cannot calculate CV, but we can assume CV based on the RPM of pinion. Pinion is rotating at 240 RPM. So by thumb rule, what is the value of CV? If it is less than 1000 RPM, we take CV as 0.4. Well, and what is the range for B? Range for B, 8.5 times of M to 12.5 times of M, and you can take any value in between, but normally we take 10 times of M. I repeat, you can even go with 9 times of M or 12 times of M, but this is just for ease that we are taking a round figure. So S naught is known, Y is known for opinion, it is 77. This is 10 M into 0.4. So give me what is FB in terms of M square. Something into M square. I'm going very fast because this is more of a revision kind, but the same design we have already done in the first part of this assembly. Is that 310? Okay, 310 M square. 0.8. What next? What is the next step? How do we get the value of M? We equate FB with FT. FB should be ideally greater than equal to FT. Equate these two terms and give me the value of module. FT is 210 10 cube by M. Make sure your values are in newtons. So it's 310.8 M square. This is in Newton because this is in millimeters, and this is in Newton per mm square. Equated to 210 10 cube. Yeah, so what is the nearest value for M from the data book? If M is 8.7, you will get 0.87 if you have not converted kilonewtons to Newton. Sushmita, make sure you are converting the units. So the next value from the preferred choice is 10 or 9. Saurabh? Okay.
10, ma'am.
10. Okay, so from data book, we are picking up M equal to 10. Now, once this is final, get the value of pitch circle diameter of the pinion. Give me what is VP. Give me what is CV. and give me what is FT. DP is 250, VP is 3.14. 10 is a magical number, isn't it? You don't have to multiply. CV 0.48 as against the assumed value of 0.4. So pretty close, which means we had to consider only um, the beam strength 48% of the actual, whereas with N240 we assume CV as 0.4, which means we assume beam strength is reduced to 40% of original, whereas it is 48% of the original. What is FT in newtons? FT value 21. Okay, so which means your value of FT was to 1.178. Okay, let me go with Saurabh. This is FT. What is the next step? What do we check now? B. Good. So now we'll assume FB as this FT, which is 21178. S naught remains the same. This does not change. Y remains the same. B we have to calculate. This is unknown now. M value you know. CV is the calculated value 0.488. So this is known, this is known, ye pata hai, ye pata hai. Give me B, and what do we check from the value of B? What do you check? Whether this calculated value of B is greater than B minimum. It must be greater than B minimum, not less. Atul, Harshini, Lokesh, I'm not getting answers from you. Okay, so Aditya, your value of B after calculation came out to be how much? 55. Pretty low. What is B minimum? B minimum has to be 85. So this is less than B minimum. This will not be safe, and therefore we are assuming B as B minimum, which is 85. We proceed with our design with B equal to B minimum. This value is not acceptable because this is less than B minimum. Okay. So now that you have increased the value of B, which means your FB is definitely greater than this 21178, which also means that now your FB is definitely greater than FT. Now your FB is S naught into Y remains the same. Value of B is increased from 55 to 85, which means FB is also greater. M is same. So this value is now with CV greater than FT. Give me what is without CV, because now we are going to check with the dynamic load. This is FB sans CV. What is 32,000? What is 66,000? 66045 without CV. Yes?
मैम ये 3 is with CV FB.
With CV. Okay. So that is definitely now greater than FT. So even in static load, this is safe. Are you understanding this conceptually? How every time we change a particular variable, how we are trying to make the gear stronger and stronger. So actually the life of gear is pretty high. We never measure the life of a gear or a bearing or a pulley in terms of years or in terms of days, but it is normally measured in terms of cycles. So how many loading cycles or how many number of revolutions of shaft it has undergone. So this is usually pretty high unless there is an impact kind of load for which it is not designed. You see, we are not designing it for impact. Next, dynamic load. FT plus FI. And for FI, we need C, we need E. Yeah, for the combination of steel and cast steel, forged steel and cast steel, which is steel versus steel. What is the value of C? Last time यहाँ गलत हो गया था. We had taken steel. It is not cast iron steel, it is steel. Yes. 11800. What about error? Check for the permissible value of error. From the graph, check for probable error. We will proceed with probable error, but you have to make sure it is less than the permissible error. As the value of E increases, look at the formula for Fi. This incremental load will increase. In the numerator, it is in terms of E. In denominator, it is in terms of root over E. Is it 0.04? Shravya, what is this? Probable or permissible? Probable is 0.04. Okay. Give me what is permissible error for the given value of BP. Karthik, roll number 20. Karthik. Ananda, please mark Karthik absent. Sai Sagar, roll number 29. Are you there? Sai Sagar. No. Sai Sagar is absent. Siddesh. Siddesh. Daitva.
Yes, ma'am. Present.
Are you solving with me?
Yes, ma'am.
You're not posting any answers?
Ma'am, I posted that points 77.77 recently.
Okay, good. Okay, so probable error. 0.08. Which class of the gear you are going with? Class 2 or class 3? Class 1. 0.08 is too high a value. This will increase your dynamic load pretty high. Class 1 gear के लिए errors are very high because it is commercially cut gear. Yes, 0.04 with class 2 gear should be good. What is the value of our velocity? Yes.
For CV, we have taken class 1.
CV, you have taken class 1. Yes, because the velocity range is lying in through 2.5 to 5. So you understand the meaning of commercially cut. It is done commercially without checking or bothering too much about the errors, and so the error is quite high. Carefully cut gear, as the name indicates, is cut with little more care, and so the error goes down. And precision cut is very precise, and so the errors are minimum. And what is the permissible error? With class 1 gear, you are getting probable 0.08, and what is the permissible error? 0.1. 0.08, and this is less. So ideally, we should write it down as we are going with carefully cut gear. But as of now, let us stick to whatever value we are getting. If it is not coming out to be safe, if this FD value is not coming out to be less than this, then we'll see. Okay? So abhi we are going with your 0.08 value. Probable error 0.08 for class 1 gear. This is what is justified as per the range of the speed. Yeah, 0.1 is little greater than 0.08. What is approximately same, Shravya?
Ma'am, both permissible and probable error.
हाँ वो तो पास पास में ही रहेंगे ना. You will get 0.04 and 0.05 or 0.035 and 0.04. इतना ही फर्क रहेगा. But you have to make sure probable is less than permissible. So you cannot cross the permissible range. Okay, give me the value of FD now. Or rather, give me what is FI first. Whatever is your calculated value, 211, कितना है 21178 plus FI कितना है 17,000. Okay, summing up to 17,699, 17,598. Okay, this much variation will accept. So what is FD coming out to be? All we want is it should be less than FB without CV. Probably it is less. Give me FD. Daitwa, give me FD. 53, oh, good. Oh, 88. All of you are getting FD in this range, which is definitely less than FB without CV. This is very important. Here we check it for FB without CV. So this is safe in bending. Okay, good. You know what is the funny part of this? When you are solving in the class, you will always get safe. When you are doing it in your exams, you will never get safe in first go. So as the joke that goes in your WhatsApp, कि class में क्या पढ़ाते हैं? Very simple model, and what is asked in exam is extremely complicated thing. So it is not done intentionally, but for somehow it so happens that in first go you never come up with the safe value of FD and FB in exams. Class में आ जाता है. So that is good for me, not good for you. Okay, moving ahead, go for FW. Check for wear, check for endurance. If you can do this in 5 minutes, we can start with the gear blank and the shaft design. So what do we do for FW? We don't assume K, we equate FW directly with the load and we find out the value of K. यही किया था ना last time. It is the pitch circle diameter of the pinion dp into the face width b into k, which is not known because this depends upon the hardness, into the size factor q, which depends upon tg and tp. So this you know, this is 2 times tg upon tg plus tp. So we want that this FW, the wear strength, should be greater than the dynamic load coming on it. So initially we take it as equal to this. So equate FD with dP, B, face width, K, Q. And this is what? This is giving you what is the minimum value of K. And then we increase the value of K from the data book so that the value of FW increases. So here to get a range of K, we are equating FW with FD. dP is the pitch circle diameter for the pinion, B is the face width that we have taken 85. Q you can calculate, give me the value of K minimum. K is coming out to be 1.08. Somebody else please confirm. Value of K 1.07. 1.07, 1.08, okay. Let's go with this. 1.075. What is the next nearest value higher than this for 20-degree involute full depth? Steel versus steel. Next higher value क्या है? After 1.07. 20-degree full depth. You are checking for 14.5. Yeah, next higher value is 1.376, which is for what BHN numbers? So from the data book, 300 each, or for 250 and 350. 250 gear, 350 pinion is again giving the same value, or 300 each. So from the data book, we are going with the next value of K, which is 1.376, which will definitely increase your value of FW. This will be greater than FD. Because DP is same, B is same, Q is same. K value from 1.07 is increased to 1.37, and so FW is definitely greater than FD. You may check, you may not. This goes with logic. And the last step is F endurance, which again for this value of hardness, where the BHN is 300 each for gear and pinion, you check for endurance and this is going to be safe. So this part for now I'm skipping because I want to go for the gear blank design. And I have to finish it in next 10 minutes because few students have requested me to leave the class at least 5 minutes before the next class, and I appreciate that. Okay, turn the pages, go to the gear blank design. I'm sure F endurance, you know by formula, will come out to be greater than FD. And we say that this is safe in bending, this is safe in wear, and this is safe in endurance. Is it okay if I move ahead? (165,427), pretty high. This is F endurance, right, Saurabh? Good. Okay, turn to page number 174 as per my book, table 1614. This is giving you the design data for gear blanks. What do you understand by gear blank? Pratyusha? Vedant? What is a gear blank? Pratyusha is there. Geometry? No. Gear blank is the solid disc from where the gear teeth are cut. Yes, it's a disc with no teeth. Now there can be three type of construction. One is a solid blank, another is a web construction, and third one is the armed construction. And now what is the difference between these three? Anybody can tell me? There are three construction given. One is the solid construction, second one is the web construction, and third one is the armed construction. Now depending upon what is the size, yeah, this type of gear blank is a solid construction and the gear teeth would be cut here on this periphery. This is the web construction. If the diameter of the pinion diameter is of the order of 24 times module plus 80 in mm or little less than this, then we go for web construction. If the diameter is less than 15 times of module plus 60, we go for solid construction. And what is armed construction? What is the DP value given in the data book? Siddharth? What is the value of DP given? Pitch circle diameter for armed construction? Are you referring to the design data book? This kind of blank is known as armed construction, where this much amount of material is removed and you simply have arms instead of a solid material here. And what is the advantage? So another probable question, when would you go for a web construction or armed construction? Or what is the advantage of this over this, or armed construction over the web construction? So as you can understand, with armed construction, perfect. There's a reduction of cost, there's a reduction of material. Perfect, Saurabh, Prajwal. So that is the benefit. But when do we go with this? If your gear is too small in size, the diameter is as low as less than 15 times of module. In our case, module is 10. So less than 15 times is only 150 mm. So you see 150 mm, which is only 15 centimeters. If this is the size, then cutting arm on this small size will be costly. But for a huge diameter, almost 240 mm, 250 mm, यहाँ तो अपना और भी ज़्यादा होगा. There is pretty much saving of material. But if in a small gear, if you are trying to remove material, then that manufacturing becomes costly. And so for smaller diameter, solid construction is preferred. For larger diameter, we prefer armed construction. And in between these two, we are using this web construction, wherein you have a rim with a rim thickness or the web thickness given. This part is known as the web. This is known as rim. Here we have this hub. And now we have to design the hub. In our case, what is the pitch circle diameter? We normally design the gear. We are designing the shaft or the gear blank for the gear which has largest diameter now. The gear which has largest diameter. Abhi 250 mm is the diameter for the pinion. What is the diameter for the gear? 142 teeth into 10 mm. Correct? Yeah. So the pitch circle diameter for the gear. Now we are designing it for the largest of the 4 pinion gear combination. And the largest one is having 142 teeth with module 10 giving 1420 mm diameter, which is definitely greater than 24M plus 80. And so we are going with the armed construction. Correct? And what will be the number of arms for this range of diameter? For the pitch diameter in mm, number of arms are given. So our value is 1420, and so number of arms would be 8, 6. 6 दिया है ना? Yes. So what will be the outer diameter of this? Pitch diameter is 1420. What will be the outer diameter? What is the height of the tooth above the pitch circle diameter known as? Yes. Addendum. Perfect. So what is the outer diameter? It is dp plus you will be adding addendum once or twice. दोनों तरफ height increase होगी ना, m plus m plus 2m. Radius will be pitch circle radius plus m, and when you are talking about diameter, you are adding that height on both the sides because it is diameter now plus 2m, which gives you 1440. Agreed? Why it is not 1430 and why it is 1440, Pradyuman? Agreed? Good, good. Abhi we have to design the shaft. How do you go with the shaft design? Achha, the shaft design we'll do in the next class. Abhi I'll just give you the concept of shaft design. You have to turn to page number 109, shaft design, which is table number 11, chapter 11, shaft and flywheel. Because shaft design part is not done, so I have to take this. Mila kya? Chapter 11, table 11.1, design of shafts. Okay, we'll be solving this in the next class, but for now, just go through this design of shaft. It's normally the design torque that we are talking about, which is P by omega 2 pi n into a factor, which is given in the next page that we can see later. Then for the maximum stress, there are two formulas. One is the simple maximum stress. Second is the maximum stress by ASME code, where there are certain factors like KT and KB given, and alpha is also given, where alpha is a factor which comes into role whenever there are axial loads. So we'll be getting axial load in a helical gear design. So when we are going for a shaft which is supporting a helical gear, then we'll refer to this table. Abhi, for this, we'll be referring to the maximum stress for the solid shaft, which I said will be going in the next class. So the tau max, the maximum shear stress induced will be 16 10 cube by pi d cube under root of m square, that is the bending moment, plus td square. This design torque you know because the power for which the shaft is designed you know, and the RPM of shaft you know. So TD you know, How will you get M? Bending moment. Suppose this is the shaft which is carrying a gear and it is supported at two bearings. There might be another gear here. Now for this particular gear, it is subjected to a radial load Fr and the Ft static load, which is responsible for power transmission. So this Ft is responsible for creating this moment and Fr is loading it in the radial direction. You must also know the length of the shaft and where are the bearings. From the bearings, we calculate what is the reaction, and from the reaction, you calculate the shear force diagram, bending moment diagram, right? Which you have already done in solid mechanics. So that is how you calculate M and TD, and from M and TD, we find out or we assume what is tau max for the material, and we find the shaft diameter. So this part we are going to start tomorrow morning 8 a.m. lecture. So that's all from my side. Anybody has any questions? Or we stop here. Thanks for your feedback. And I want others also to post their feedback. It is anonymous. And any suggestions if you have for improvement is most welcome. Anyone has any doubts? Nikhil? Vineet? Yes? Okay, you are free to leave then. Thank you. Which textbook to refer for solving questions? The book that I am referring for solving question is Design of Machine Elements, again by B.D. Shibalkar. The other books like Machine Design by Shigley, Machine Design by Thomas Bevan, which I am referring for the theory part, you will not get any numericals there. So any other design book, machine design book by Indian author is okay. Wherever you will get number of solved problems. Each book will have a different approach of solving numerical. I would suggest you to follow this step because this one would be the most easiest and a precise one. Refer any book and you would get a similar kind of answer. Till 2017, Professor Padole was teaching this subject and I attended his lectures for 2 years and then I started teaching. So I am word to word following his method of teaching or his method of gear design. And so you can safely rely on this particular procedure which is given in B.D. Shivalkar. So other than design data book, there is a book of design of machine elements which has lot of solved numericals. Okay, Aditya? Okay, good. So we stop here. Anybody else? Any more questions?
Ma'am, I have one question.
Yeah, please.
Yeah, ma'am, actually, I was solving the same question for the second pair myself. And
Okay.
ma'am, in my case, I got CV value that was the calculated CV value was greater than the one which was assumed initially. Like
Okay.
mine assumed was 0.4 and the calculated one was 0.48. So
Perfect.
what shall we do in that case?
We will go with the calculated value because the assumed value was just to get a range of FB.
But again,
Ideally,
0.4 is still like a safer and more conservative approach, right?
0.48.
I mean, the lower value is
0.4.
always more conservative and more safer.
Yeah, but we are checking for FD also, and if the FD value is much safe, then even if you go with 0.48, you are in the safe zone. There is no point in being too safe because then the cost increases, right? Yeah.
All right. Thank you, ma'am.
Right. Anybody else has any other question? No more questions? Okay, good. So we stop here. Thank you.
Ma'am,
Yes.
I have a question. What should be first preference while designing? More safer side or the more efficiency?
Normally, safety first. Normally,
Okay.
you will have a list of, say, priorities or preferences. There are few applications where precision is more important than safety. There are other applications where safety and precision they go hand in hand. Suppose in an aircraft application, safety is equally important as that of precision. You agree? There could be an application in industry where each gear is enclosed inside the gearbox, and so safety is not very much a concern, but for them efficiency might be a bigger concern. As an engineer, it's always better to keep safety as your first priority, but it should not have a factor of safety as high as 3 or 4 or 5, because then the cost increases.
Okay, ma'am.
Right? So make sure that your factor of safety is in the range of 1.5 to 2. You are pretty safe and your cost is not enormously high.
Okay, ma'am. Means it depends upon industry and
Yes,
all such
it
things,
depends
right?
upon the application.
Okay, ma'am. Okay. Thank you, ma'am.
Yeah. Is that all? Yeah, Shantanu, Tanvi, no more questions? Okay, thank you.